All right, this is day 2 of compound inequalities. We're going to be looking at objective number 2 today, the special cases involving these types of inequalities. A quick review: compound inequalities containing the word and are referred to as intersections or overlaps. You can see what a typical intersection would look like here. That's the purple graph. And recall that for a number to be a solution to this type of inequality, it has to satisfy both sides of the inequality. It has to make both of them true. Compound inequalities containing the word or are referred to as unions, and they typically will graph to look like what you see in purple here. For a number to be a solution to this type of inequality, it only has to make one if not both of the inequalities true. So one or both of the inequalities have to be true for it to be a solution. All right, so now we're going to look at the special cases involving intersections. So these are less common, but they can still come up, and these will really test your understanding of the difference between unions and intersections. All right, for all of these examples, I have the initial inequality written out, and we're going to graph that on a number line and use that initial graph to help us visually see where the intersection takes place so that we can then finalize our solution. Okay? All right, so the first inequality here, we have x is greater than 3 and x is less than -1. I'm going to graph x is greater than 3 first, then x is less than -1, and I'm using these two lines together to see where the intersection or overlap takes place. I'm noticing that there is none. That means that there is no number in the entire real number system that will make both of these inequalities true. Therefore, I can say that my final solution is actually no solution, which means my final graph would have to be blank. Okay. Next special case, x is greater than 3 again, and x is greater than -1. So notice these lines both point towards the right-hand side in the positive direction, and notice where the overlap is taking place at the numbers that are greater than 3. So my final graph needs to represent that, and I can rewrite my inequality for the final solution as just x greater than 3. Okay. Think about it. If you go back and you look at the initial inequality, all the numbers that are greater than 3 are already greater than -1. So it's redundant to put that greater than -1 in there. Okay. All right, last one. X is less than 3 this time, moves to the left. X is less than -1, also moves to the left. So this is going to be a similar situation, just headed in the negative direction. Notice where the intersection or overlap takes place. It is at any number smaller than -1. Okay. Moving on to the special cases for our unions. All right, first example, x is less than 3. Or x is greater than -1. And remember what or implies. You want all of the numbers that make one, if not both, of the inequalities true. So we're treating the blue and the red curves. We want to find the union of those two. Together, notice that they are covering the entire number line. So I can say that my final solution is actually all real numbers. Okay. X is greater than 3 goes to the right. X is greater than -1 also goes to the right. All right, now don't confuse this with the intersections, right? We're not looking for the intersection now, we're looking for the union of the two. So bringing those two together actually creates all numbers greater than -1. Okay. And the last example, x is less than 3. Or x is less than -1. Try to find the union of those two. Together they make any number less than 3. All right, so notice how those last two examples, and it was the same with the last two examples on the intersections, that sometimes what's presented as a compound inequality can really be rewritten more specifically as a simple inequality. All right, let's see these show up in some examples. All right, here we have a intersection at play, and I'm just going to solve each side separately. Make sure you bring that word "and" down. And then let's go ahead and graph. So okay, I'll do x is less than 3 in blue. X is less than or equal to 8 in red. And now I'm paying attention to the fact that "and" separates those two inequalities. That implies I need the intersection of the red line and the blue line. Where is that taking place? It's taking place at any number smaller than 3. So that's my final graph, and I can simplify my final solution to x less than 3. Okay, example 4. All right, so this one was a union. Solve them separately. Be careful on this first one. Notice you are dividing by a negative. That requires the inequality symbol to flip. And over here, subtract that 10. Carry down or. All right, let's, I'll label by 2's this time. Okay, we'll do n is less than or equal to 7 in blue. N is greater than or equal to -6 in red. Or implies a union, so if I take the blue and the red graphs and find their union, I'm going to end up with the entire number line. All real numbers is my final solution in this case. All right, pause the video. When you move on to these next two examples, you try them yourself, and then when you're done, start the video back up and check your work.